Welcome to Friday. I won't be here today, so you won't have a Zoom meeting. We will have polygenic conversation and a sex-linked trait conversation. We will try to still meet our goal of having the test on Friday before we leave. The worst comes to worst, we'll take out cell division as meeting that mark, and then do the cell division after we come back from break. I did want to mention that less than half the students are turning in their work, which means that if you don't pass the exams, you're probably going to have a pretty tough time passing the class. I also have not heard anything about the final exam being offered the way it was first semester. It may not be offered that way, considering you will be back in the building basically full time, exempt of Monday. So I'm just trying to warn people where they are, and if you're not doing well, you may want to start picking up the pace. It really is important to pass this, because otherwise you'll be taking this class again in the future. And I would prefer you not do that, because you deserve to move on to higher levels and move into getting closer to graduating rather than starting at the beginning. So let's step it up and get her done. Okay, the first thing on here is color blindness. That is a sex-linked trait. You're going to read about this and then we'll talk about it later. This here is a blood typing sheet. I wanted to show you, it shows the groups. This is from a textbook. You're going to see over here the blood groups over here on the left, and it's going to have AB, which is the co-dominance, because it's A and B here coming together to make blood, because neither one's willing to give up. They show up just as they are in the makeup of AB blood. So you have AB, B, A, and O. Remembering A, B, and O are the only groups of blood. This is just the codominance. If you look over here, we're going to ignore the middle. I didn't mention this part here. This is the frequency. This is how likely you'll find it in population, the percentage. So if you look here, it shows you the population that you'll see in whites having that type of blood type, blacks having that type of blood type, and Asians. Skip the middle here because I haven't talked about this, and you'll learn about this later if you take classes in college or move on to take higher classes even in high school. This is talking about who can receive what type of blood. So AB blood type can receive any of the blood types. They're called universal recipient. So any blood type, they can receive it if they need it. If they needed a blood transfusion, they could receive anybody else's blood. B blood can receive B blood and O blood. A can receive A blood and O blood, and O is the universal donor, meaning it can donate to all other blood types. So you have AB who can get all the blood, you have O who can give all the blood, and the only thing O can receive is O blood. So it's quite interesting. And the last thing to mention is, if you look here, you can see which is the most common. Look at the population. You're looking at almost 50% of the population having O blood type. And then think about that likelihood that you have O as a universal blood type. You have it where most, 50% of the population carries this type of blood that helps everybody else on the planet. Pretty interesting. And the most rare is going to be AB blood, right? So I find that interesting. Okay, the next thing on here is the PowerPoint. It has in there the sex-linked traits. It's the full PowerPoint, but I just am focusing on traits today for sex-linked. But here's our first definition we're going to cover that we mentioned today. Polygenetic traits. It's talking about many genes linked to one trait. So we had the dihybrid where we had 16 squares. This is even bigger. This is crossing over more than one trait at a time, and more than two at a time. So we're looking at being able to see the possibilities of these crossing over and making several different options. So you see here the options of where they're connecting the hair, eye, skin, all combining to make these options, right? So what it's talking about is, it's not as simple as saying what's my child's hair color going to be, or their eye color going to be, or their skin color going to be. We may talk about them simply when we're trying to teach it in a scientific manner, but the truth is these are all connected to one another inside your genes that make them express differently. That's why we all have different colors of dark hair or light eyes or dark skin or light skin. It's all varied colors because they're all linked to many genes at one time combining to make that expression that you see. Because remember, genes we don't see, we see the phenotype, what they look like, and then we see that varying options. Okay, so let's move on to our sex-linked traits. We're talking about traits and disorders because you will see that when we talk about some crosses that we might do. But here is the chromosomes that exist in our bodies. This is just an example of one. It's called a karyotype. So in the end here, you're going to see, you see we have 1 through 22. The 23rd chromosome is your sex chromosomes. The Y is going to be the smaller one. The X is going to be the longer one. So this here, this karyotype is showing us a female. When I say female and male, I'm talking about biological origination. When you were born, what anatomical parts were you born with? Were you born with ovaries? I'm going to refer to that as female. If you were born with testes, and I'm going to call that a male. So if I mention that in the future, while in this conversation of genetics, I'm referring to the biological, what you were born with, anatomy. So let's make sure that we are on the same page with that. So, like I said, it's the 23rd pair of chromosomes in your cells that determine your sex. So the 23rd pair is called the sex chromosome. It makes up your biological, whether you're male or female. If you're genetically born a female, your anatomy would be XX, or your chromosomes would say XX. If you were a male, it'd be XY. The eggs are from females, they carry the X chromosome. The sperm can carry the X and the Y, so that's why sperms determine the sex of offspring. They can either donate an X to the egg, or they can donate a Y to an egg. If they donate an X to an egg, it's going to be a female. If they donate a Y to an egg, it's going to be a male. So, eggs only give X's, and sperms can give X or Y. When we talk about sex-linked genes, we're talking about it being carried on the 23rd chromosome, which determines the sex of an offspring. That is why males tend to have sex-linked traits, because females have the two X's, which allow them to cover up genetic disorders or traits. So, when a male has it, he doesn't have that extra X to cover up. He actually has it. So what women become if they have one X affected is called a carrier. We'll see that when we practice. So, one of the most common sex-linked traits that are usually talked about are colorblindness, so we will see that. I'm going to stop the video here so we can do the lesson separately. So I'll put a video down here to go with the assignment down here, so we can make sure that if you need to go through the video part of the assignment, you can do that just on its own without listening to the whole thing. The last part of today is to finish this assignment. I will leave a video going through all the answers, so be sure you watch that video to get some help and complete that assignment. If you know what you're doing, then obviously you don't have to watch that part of the video. But I'll talk to you Monday. Have a great weekend.